Hi, today we're going to start chapter 9 and look at section 9.1, which is called Graphing Quadratic Functions. Up until now, all the functions that you've mainly worked with have been linear functions. Okay, the y equals mx plus b equations. And if you remember the graphs of a linear function, they were all straight lines. Okay, and they had a slope that counted up and over and a y-intercept where it crossed the y-axis. Okay, but the main thing is that the graph was a straight line. And the largest power, the largest exponent you saw in those equations, if you remember, it was y equals mx plus b. And the largest exponent was 1, even though it wasn't written there sometimes. But that's what it was. Well, today, when we talk about, this whole entire chapter is going to be about quadratic equations. And a quadratic is when the largest exponent is a 2. Okay, so we're going to be looking at the graphs of x squared functions. Okay, this is the general form of a quadratic equation. Okay, you can see it has 3 terms. It has an x squared term, an x term, and a constant term. Okay, and the number in front, the coefficients, okay, there's an a and there's a b, and then, like I said, the constant is a c. Okay, a good example, this one might be something like 3x squared plus 5x plus 2 or something. Okay, and we're going to look at the graphs of these quadratic equations. Okay, that's the general form of a quadratic. Well, if you remember this thing called the parent function, it's kind of like the plain Jane, the smallest, most basic equation of a quadratic, or of an equation. This one is the quadratic, it looks like that one. Okay, and this is really the same as standard form. It's y equals 1x squared plus 0x plus 0. There is no x term, there is no c term, and the coefficient is a 1. Okay, well, let's see what the graphs of these quadratic functions look like. Okay, I'm going to grab my calculator here. Okay, and I'm going to type in y equals x squared. Okay, now I'm going to press graph, and there it is. Okay, well, you can see it certainly isn't a straight line. Okay, it's this U-shaped thing. Okay, and this U-shaped thing has a special name. It's called a parabola. Okay, a parabola. Okay. Now, a parabola has several specific special parts to it. Okay, first of all, it's not straight, it's a curve. It's a giant U. Okay, just to clarify, down here, it's not a V. Okay, it doesn't have a point to it. It's a curve down there at the bottom. Okay, and right down here at the bottom, there's a special name for this point. It's called the vertex. Okay, and on the parent function here, the vertex is a special point, and it's right at the origin, 0, 0. Okay. A couple other things about these parabolas, okay, is that they're symmetrical. And if you remember, symmetrical means it's equal on both sides. If I cut a line right down the middle, and I folded it over onto the other side, it would match up perfectly. Okay, well, there's a special name for this line that cuts it in half. It's called the axis of symmetry. And sometimes I abbreviate that AOS, and you can certainly do that as well. Okay, well, the axis of symmetry is always going to be a vertical line. And if you remember from a long time ago, we had an equation for vertical lines, and it only had one letter, and it looked like this. It was always x equals something. Okay, the equation of a vertical line is x equals. And the x, or this line of symmetry, is always going to go through the vertex in order to cut it in half. And the equation of this axis of symmetry is always going to be the x coordinate of the vertex. So in this particular case, it would be x equals 0. Okay. A couple other things about parabolas. Okay, is that most of the time they're going to have a y-intercept. Okay, and if you remember, the y-intercept is the point where the line crosses the y-axis. Well, here's the y-axis, and in this particular case, it crosses right at 0. So the y-intercept is at 0. It's not always at 0, as we'll see here shortly. Okay, but we're just sticking with this parent function one. Okay. Another thing about parabolas is we can describe the domain and the range of parabolas. And we're going to be finding all of these things and labeling and describing all of these things today when we graph these. Okay? But the domain and the range, if you remember, the domain talks about the x values. Okay, what possible x values can there be? And the x values talk about how far left and right the graph goes. Okay, well, this graph is going up, but it's going to the right. This one's going up, but it's going to the left, and it's continuing to get wider and wider and wider. So the x values go to the right forever, the x values go to the left forever, and it's everything in between. How do we describe all the numbers to the left and to the right and in between? We describe them as all real numbers. Okay? And there's a symbol for that. It's like this capital R with two lines. That stands for all real numbers. If you would rather write all real numbers, you sure can. Okay, but I'm going to use that symbol. Okay, when we describe the domain, we should make sure we write x equals all real numbers. Okay? In describing the range, if you remember, the range deals with the y values, and the y values talk about how high or low the graph goes. Okay, well, the u here, the parabola is going up forever on that side, up forever on this side, but it doesn't go down forever. Okay? It stops right here. It has a low point. And the lowest point of this particular parabola is 0. And there's a special relationship between the range and the y coordinate of the vertex. Okay, but the lowest it goes is 0, and the graph exists everywhere from 0 and higher. So how do I describe all those y values from 0 and higher? We describe them by saying all the y values are greater than or equal to 0. And again, it's not always at 0. Excuse me. Okay, as we'll see here shortly. Okay, but one last thing here. When I talk about this parabola and talk about its vertex, and specifically its range, on a parabola that opens up like this point right here is a low spot. The vertex is the lowest point of the whole entire graph. And there's an M word that we use to describe that lowest point. It's called the minimum. Okay, so right down here is going to be the minimum. Okay, sometimes we're going to have parabolas that open upside down, that open this way. Okay, and up here, instead of a low point, it's going to have a high point. And that high point is called the maximum. Okay, so a couple different things here. Okay, domain, range, y-intercept, vertex, axis of symmetry. Can we find its maximum and minimum, its high point and its low point? Okay, well, they're going to occur at the vertex. Okay. All right, so we kind of have a general idea of what a parabola looks like. Okay, we have some idea about the different parts of the parabola. Okay, let's take a look at what we have next here. Okay, this page right here is in your book, and it kind of describes all the stuff that we just got done talking about. Okay, it talks about the standard form right up here. Okay, the parabola, the axis of symmetry. Okay, you can see the vertex, and it labels all those different parts right over here as well. Okay. Okay. All right. How about this? Okay. On these two problems, can you help me name these different parts? Okay. We want to name the vertex of each one, the axis of symmetry, and the y-intercept. Label this here. We want the vertex, the axis of symmetry, and the y-intercept. Okay? All right, looking at the one on the left here. Turn this off for a second. Okay? It's vertex, right there. Its vertex, if I was to name that point, it's at left 1, up 3. Left 1, up 3 is how I would name that vertex. And I'm just going to make a mental note here. Is that vertex a maximum or a minimum? Is that vertex the highest point or the lowest point of that graph? It's the highest point. Okay, so I'm just going to store this in the back of my mind here for later. That right there is a maximum. That's the high point. Okay. Next item up for bids here is how about the axis of symmetry? Okay, where's the line that cuts this parabola in half? Well, it's right here. It goes right through the middle of that parabola. Okay, and if you remember, the equation for the axis of symmetry is always going to be x equals something. Well, what x value did that axis of symmetry go through? It went through -1. And there it is. And as I said earlier, the axis of symmetry is always going to be the x coordinate of the vertex. Okay? And last but not least, how about the y-intercept? Can we name the point where this graph crosses the y-axis? And if you look carefully, it's right there. Okay? And what is the name of that point? It's 0, 2. Okay, now when you label the y-intercept, you could just label it 2 if you wanted to. Or what I personally like doing, I like just naming the point 0, 2. Okay? So just naming the different parts here. Okay? How about this guy on the right here? Does it have a vertex? Yep, it's right there. Can I name that point? It looks like it's right 1, up 3. Right 1, up 3. And in my head here, I want to know about this right now. Is that vertex, is that one a maximum or a minimum? Is it the highest point of the graph or is it the lowest point of the graph? Well, that's obviously the lowest point of the graph. So in this particular case, that vertex is a minimum. Okay? The axis of symmetry, if you remember, is always going to be an x equals something. And if I draw a line through the middle, it goes through 1. Or if you remember, x equals 1. It's the same as the x coordinate. Okay, does this one have a y-intercept? Does it cross the y-axis anywhere? Looks like it crosses the y-axis right there. 1, 2, 3, 4. And the name of that point is 0, 4. Okay, so there's not a lot of fancy math here today. Okay, but we're going to do a little bit of graphing and we're going to be labeling and finding all of these different parts of the parabola. Okay? All right. Like I said a couple minutes ago, these are the different things that we're going to find on every problem. Okay? Our assignment today is going to be a worksheet, and I'll kind of have these things all labeled out for you. You just have to fill them in, and then ultimately you're going to have to draw a picture of it. Okay, and we're going to use the calculator to help us draw a picture of it. Let's take a look at a couple. Okay? So I have an equation right up here at the top. Okay? The quadratic equation, 3x squared plus 6x minus 4. And we're going to try to find all these different pieces. So you're going to need two things today. You're going to need your graphing calculator, and you're going to need a piece of graph paper. Okay? Graph paper would be helpful, I think. Okay? All right, so first things first, to graph this, we got to type in the calculator. So I'm going to go to y equals, and I'm going to type in 3x squared plus 6x minus 4. And then I'm going to press graph. Okay. Now again, if your window is kind of messed up or different from a previous problem that you did somewhere along the line, we want to reset it to the normal 10 by 10 screen. So I'm going to press the zoom button, and I'm going to go down and hit number 6. Zoom 6 and press enter. And we should all get this picture on our screen. Okay. Okay, so ultimately, like I said, we're going to want to make a graph. Okay, so, and if you have graph paper, great. If not, you can certainly make a sketch on your paper, but make sure you draw these things nice and neat. Make sure you draw the little tick marks. Okay, you don't necessarily have to label them, okay, but you do need to draw them so I can count them and you can count them. Don't make them so close together that it's hard to count. Don't make them so teeny, teeny, tiny. Okay, but make it nice and neat. Okay, first things first, we need to find the vertex. Okay, well, I can kind of see it looks like it's left 1 and down something, but we're going to use the calculator to help us with that. Okay, and in order for the calculator to help us with that, we need to first of all determine, is this one a maximum or a minimum? Is the vertex a high point or a low point of the graph? Well, it's way down here. The graph opens up. Okay, and one way to tell that the graph opens up while I'm thinking about it is if the first number is positive. If that A is a positive number, it's going to open up and it's going to have a minimum. Okay, this is the lowest point, so it's going to have a minimum. And the reason why that's important is that the calculator can find that minimum point for us. And here's a new thing for us now. We're going to go second trace. Second trace, and look right here, number 3 and 4 are maximum or minimums. Okay, and we want to find the minimum in this case, so I'm going to go down to number 3 and I'm going to press enter. Okay, now here's kind of a new thing too, I think. The left bound. If you can see my cursor there when I move it, okay, what it's wanting me to do is it's wanting me to move my cursor on the left-hand side of the vertex. Okay, And the left-hand side is going to be down and around and somewhere over here, just a click or two. Okay, on the left-hand side, and I'm going to press enter. Then down at the bottom, down there, it says right bound. Well, we want to move our cursor down and around to the other side of the vertex, a click or two. So my right bound is down here. Okay? Okay, and then I'm going to press enter. So what we're kind of doing is we're boxing in the vertex. If I press enter, it's then telling me to make a guess. And if I want to, I can move that cursor down there kind of close where I think it is, where I think the vertex is going to be, and I can press enter again. Okay? And you can see my vertex is at -1, -7. -1, -7. Okay, so that's how we're going to use our calculator to find the vertex. So we're going to determine if it's a maximum or a minimum, and we're going to go second trace on our calculator, choose the maximum or minimum, and then do the left bound, right bound, and guess. Okay? So if I make that, and what I like to do is, since I'm ultimately going to have to make a graph, I put that on here. -1, 1, 2, 3, 4, 5, 6, 7. So it's going to be about right here. Okay, now what I see in a lot of my classes over the years is people do that and then they just draw a curve. No. Okay, when you do these, I need to see other points. How many other points on your graph? As many as you can. Okay, as many nice points, I guess. And where does the calculator have many nice points? Okay, right here on the table. And we've used this table before. And table is right above graph. If I press second to graph, there's a whole bunch of nice points. Okay, and a lot of times, especially when our vertex is a nice number, what I oftentimes like to do is I like to adjust my screen a little bit so that the vertex is right in the middle. Okay, and then ideally what we want is we want a couple points on this side of it and a couple points on this side of it. Okay, and like we said before, we're mainly going to use the numbers when the y values are between -10 and +10. Here I go from 5 to 5. And then 20 gets to be too big, just because 20, our graph paper doesn't go up to 20. Okay, so I'm going to graph a couple of these points. -3, 5. Left 3, 1, 2, 3, 4, 5 up here. Okay. -2, -4. 1, 2, 3, 4. It's about right here. 0, -4. Where we're at here, 1, 5, over 1, up 5. Okay, and oftentimes when we graph these parabolas, our table lists the points that are straight across from each other. And then what I do is I go down and I connect them with a curve. Again, it's not a V, it's a curve. But I want to be crystal clear here from the very, very beginning. When you graph these, I need to see points on your graph. 1, 2, 3, 4, 5. And like I said, sometimes the table will give you more than that. Other times it maybe doesn't give you quite that many. But you need to have for sure the vertex and at least 1 or 2 on each side of it. Hang on a second. Okay. So there's the graph. And again, graph paper I think is helpful. Exaggerate these dots so that I can see them. If I see something that's just like this, without any points on it, I don't give you credit for it. Okay, your graph needs to be somewhat accurate. Okay, well, once we got this, we can answer a lot of these other questions. How about the axis of symmetry? If you remember, the equation for the axis of symmetry is always x equals something. Okay, and it's the line that cuts it right down the middle, like this, and it goes through, in this case, -1. And if you remember, it's the same number as the x-coordinate of the vertex. X equals -1. The y-intercept is where does the graph cross the y-axis? Well, I can see it does right there, but there's another place that we can look that's going to always tell us where the y-intercept is. The y-intercept is the value of y when x equals 0. Okay? And you can get that from the table very easily. Okay, so the y-intercept in this case is 0, -4. It's a really easy way to find the y-intercept. The domain, remember the domain talks about the x values. Okay, and this parabola here, again, it's going to the right forever, to the left forever, everything in between. The domain on these parabolas is always x equals all real numbers. Okay, The range we know is the y values. Okay? And right down here, that's the lowest it goes. And the lowest it goes is -7. And this graph exists everywhere above -7. So all the y values are greater than or equal to -7. So again, there's not a whole lot of fancy math here. Okay, it's just graphing it, using our calculator to find some points, and then labeling the different parts. Okay, let's try another one here. I'm going to skip ahead to this one. Okay, so same type of thing. I'm going to graph it on my calculator. So I'm going to go to y equals. Let's see what the graph of this one looks like. Y equals, this time it's a -3x squared plus 6x minus 5. And before I do this, if you remember me saying on the last one, if the very first number in front of the x squared is negative, that means it's going to open down. It should be a parabola that goes this way. Okay, and if I press graph, let's see what it looks like. Sure does. Okay, so if I want to find the vertex here, and I'm going to use my calculator to help me do that, I need to know, does that one have a maximum or a minimum? I know the vertex is located right here, but ask yourself, is that the high point or the low point of the graph? Well, that's the highest point on the graph, so in this case, this one has a maximum. Okay? And to find that maximum, once again, I'm going to go second trace on my calculator. I'm going to go down here to number 4, and I'm going to hit enter on maximum. And again, it's going to ask me the left bound and right bound thing down here at the bottom. The left bound means I want my cursor to be on the left-hand side of the vertex. Just a couple clicks. Okay, it's actually okay where it is, but if I move it a little closer, right there. Then I press enter. It's then asking me for a right bound. The right bound, I have to go up and over the hump, and I have to be on the right-hand side of the vertex. So I'm going to go use my right arrow, go up and over, a couple clicks, and press enter. Guess means I can try and move that cursor right back to where I think that high point is and press enter. Okay, and look at this, 0.9999999. With all those nines, that's pretty darn close to 1, isn't it? Some of your calculators are going to say exactly 1, and why some do, some don't. But when it's all 9s like that, we're going to round it up to 1. So my vertex is at 1, -2. Okay? And again, ultimately, I'm going to be looking for a graph here. There's my vertex right there. Oops, shoot. Okay, and I like drawing it in there right away. Okay, can we find some other points on this graph? Okay, and the way we do that is we go to the table. Okay, so I'm going to press second graph on my table, and I like to see, can I find that vertex 1, -2? Yep, there it is, right here. Okay, now this time, okay, I got a couple points. I got 0, -5 down here. And then I can find 2, -5, which is on the other side of it. And then if you notice, the y values get to be big, don't they? I don't have -14 squares. I don't have -29 squares. Okay? In this particular case, I just have the vertex and then one of them on each side of it. That'll be good enough. We can draw it in. Okay, but we want to draw as many of these nice points as possible. Okay, so there's a picture of it. Okay, the axis of symmetry. It's x equals something. And if you remember, what does x equal? What's the x value that the line of symmetry goes through? It's the x coordinate of the vertex. And it might not be a bad idea to write some of these things down. The y-intercept, I find by going to my table. It's the value of y when x is 0. It's right here. There's my y-intercept. When x is 0, the y value is -5. In describing domain and range, if you remember, domain is the x's, and make sure you write the x's. It's always equal to all real numbers. And then the range is our y values, and again, make sure you write the y's. And let's look at our y values. Okay, we said that this is a maximum right here. This is the highest that point gets, and everything else is below it. Well, what number is that? That's -2. And everything else is below -2. So in this case, all the y values are less than or equal to -2. And there we have it. Okay? But those are all the different pieces, all the different parts we want to make sure we label and have on our graphs. Okay, and just so we're all crystal clear, once again, make sure we have the points labeled. Don't just draw me a U without points. I need them. Okay, the more you can draw, the merrier. Okay? All right. If you want to, take a minute, push pause. See if you can try one by yourself. See if you can graph it on your calculator. Draw me a little picture of it and label all these points. Okay, push pause. When you're done, push unpause and we'll do this one together. Ready, set, go. Okay, welcome back. Let's give this a whirl. Let's try it. Okay, I'm going to go to y equals. I'm going to type in my equation. 2x squared plus 2x plus 2. And I'm going to graph it. There it is. Okay, and ultimately in the grand scheme of things here, that's what I'm looking for. I'm going to try to make a graph. Okay. The single most important part of this graph is always going to be the vertex. Okay, and I need to determine, to have my calculator find it for me, I have to determine in my head, is it a maximum or a minimum? Well, it looks like the vertex is right down here somewhere. To me, in this case, it's the low point of the graph, so it's a minimum. Okay, well, can we find that minimum value? Let's go to my calculator, and I'm going to go to second trace again, and I'm going to go choose number 3, minimum this time. The left bound, I'm going to swing to the left-hand side of the vertex and press enter. I'm using my left and right arrows. My right bound, I'm going to use my right arrow and come around to the right-hand side a click or two and press enter. And I guess I'm going to go back right to the middle, closest I can get, and press enter. Okay? Oh, now this one. Look down here at the bottom. It's giving me the coordinates of my vertex. -0.5, 1.5. -0.5 and 1.5. Does the vertex always have to be a nice number? No. The vertex can be a decimal. That's perfectly fine. Okay? And oftentimes they are. Okay? But when we graph it, let's just make sure we graph it accordingly. So -1/2 up 1.5 is about right there for my vertex. Does that look like it's about right? -1/2 up 1.5, yeah. Okay, and when you do, this is where graph paper is helpful. Okay, it should be at half a square to the left and 1.5 squares up, so it should kind of be in the middle of a square if you're using graph paper. Okay, we need some other points. So even though the vertex is a decimal, if I go to my table, the way my calculator is set up, the calculator is set up is only going to give us nice points. And it looks like I have a bunch of them from 6 to 6 here before the numbers get to be pretty big. So I could do -2, 6, -2, 1, 2, 3, 4, 5, 6 up here. -1, 2, 1, 2, oops, sorry, 0, 6, my bad. 0, 6 is way up here. No, wrong one. 0, 2, shoot. Couldn't read it. Over 0 up 2, and then over 1 up 6. So that's what my graph looks like right there. And then again, I can connect it with, oops, a nice little curve. Okay, we put little arrows on the top, and there I have it. Okay, again, that's not the greatest picture there. Should be right there. Okay. So this one should have the vertex plus 1, 2, 3, 4 other nice points. Okay, the axis of symmetry. If you remember, it's the x-coordinate of the vertex, -0.5. The y-intercept is the value of y when x equals 0. Well, we can get that off our table. When x is 0, the y value is 2. It crosses the y-axis at 2, and we can certainly see that right there. The domain, x always equals all real numbers. And the range is always going to be y, and y is going to be greater than or equal to or less than or equal to something. Well, right here, okay, that's the lowest that graph goes. Okay, and everything is above that number. What is that number? 1.5. Again, it goes with the vertex. So y is greater than or equal to 1.5. And again, that number is coming from right there every single time. Okay? Very good. And again, if you need to rewind these, look at them again, please do. Okay? It's kind of an important thing. Okay? All right, so can we, if I give you an equation, can you graph it on your calculator? Can you find all these different pieces? Okay? All right, last thing here is this equation. Okay, we've seen this equation before. It's called the vertical motion model. And there's different parts to it. Okay, and this is probably worth writing down again. Okay, this is called, the H there is called the ending height. T stands for time. Velocity, and this H sub 0 stands for the starting height. Okay, and this actually has the same form. It's a quadratic equation. It looks very similar to this. But instead of x's, they use t's. Okay? It has an a. V, the number in front of the t, is going to be b. And then c, the constant at the end, is the starting height. And this vertical motion model is used to find the height of an object after a certain amount of time that goes by. Okay? We're going to use this equation to help us solve a couple word problems. Okay? And we're going to do these all the same, and we're going to use our calculator to help us with it. Okay? Here's an example of one. The cheerleaders at the high school, they launch t-shirts. Maybe you've seen those t-shirt launchers at different sporting events or something. Okay? But they launch them up into the crowd. Okay, when they launch them up into the crowd, they follow a quadratic equation. And they make a parabola. Okay? And so anytime we do word problems, when it says to graph, we're going to use our calculator to graph it. If you were to graph this on your calculator, this is what it would look like. You would probably, you would have to adjust your window so that you can see the whole path. You'd have to make your y maximum, look how high this goes. You'd have to make your y maximum on your window go above 40, maybe like 50 or 60 so that you can see it. Okay? Okay? And let's see if we can answer these questions here. Okay, so there's the graph of it. Letter B, at what height was the t-shirt launched? So at what height was its starting height? And there's a couple places you can look. Right down here is its starting height. But if you remember from the equation, the starting height was the very last number. In this particular case, the starting height is 6. 6 feet. Okay? Letter C, what is the maximum height of the t-shirt? Well, that's going to occur way up here at the vertex. Okay? Now, to find that vertex, I think we need to graph this. Well, we should have graphed it in my calculator in the first place. So I'm going to go back here to y equals real quick. Okay, I'm going to type in that equation. Negative 16x squared plus 48x plus 6. And like I said before, if I graphed it, I don't see very much there. Can't see anything. Okay? But it started here at 6. It actually went up, and then it's coming back down right here. I think it's a good idea to adjust your windows every time so you can see the point. And like I said, the y maximum, I'm going to make up. I'm going to go up to 50. Let's see what that looks like. There, I can see it. Okay. Okay, and I want to find this maximum height. I want to find the vertex. Okay? So I'm going to go to second trace. I'm going to do maximum, since that's the high point that I'm looking for. You can see my cursor here. I need to put it on the left-hand side of the vertex, a click or two. Press enter. My right bound, I'm going to go up and over the hump and press enter. And my guess, I'm going to get as close as I can and press enter. And there it is. Okay, now what's that telling me? It's telling me it has a vertex of 1.5, 42. What does that mean? Okay, it's over 1.5 and up 42. Okay, which one of those numbers actually describes the maximum height? How high it went? Is it the x coordinate or the y coordinate? This was 1.5 and 42. Okay? The y-coordinate is actually the one that tells you how high. Okay, so that says height 42. Okay, well, what's the significance of the x-coordinate then? Okay, down across the bottom here, this is time. This tells us that it took 1.5 seconds for it to get up to the top. Okay, and remember this is halfway. Okay, when was that maximum height reached? 1.5 seconds after it was launched. Okay, and we could ask us how long was it in the air? Well, if this is the halfway point, if it took 1.5 seconds to get that high, it's going to take 1.5 seconds to get back down for a total of 3 seconds. Okay? But when we do word problems, we're going to graph it on our calculator. You're more than likely going to have to adjust the window, and oftentimes it's the y maximum so you can see up higher. Okay? When it's asking for the maximum height, it's asking for the y coordinate. Now, if you want to write them both, you sure can. Okay, but the actual height is the y-coordinate. And then the x-coordinate here tells us how long it took to get there. So make sure you read the question, whether if it's asking how high or how long. How high is the y-coordinate? How long is the x-coordinate? Okay? Okay, last one. Let's see if we can do it. Okay, on these word problems now, it says to graph. You do not have to graph on paper. The graph we're always going to do just right on the calculator. Okay, and we'll use our calculator to answer the other questions. So before I do this, I got to type the javelin in here. Old Emilio's doing the javelin throw. So I'm going to go to y equals negative 16x squared plus 64x plus 6. Okay, and if I graph it, I still have my same window settings from the last problem. And you can kind of see it goes up. I can't quite see the whole thing, and then it comes back down. I need to see up a little higher yet. So I'm going to go to my window. The one that allows me to see up higher yet is the y maximum, and right now it's at 50. Okay, maybe I'm going to go up to 100. Okay, and when I get up to be pretty high up there, I like to count by, instead of counting by ones, I'm going to count by twos. Okay? There I can see the path of the parabola, or the javelin. Okay? Okay, so for part A, that's all we have to have. At what height was the javelin thrown? Well, if you remember, this is kind of asking us for its starting height. And if you go back to the equation, the starting height is that very last number. Okay? And in this particular case, it started 6 feet high. And it's kind of hard to tell here, but it started right there at 6 feet. And then it went up and came back down. Okay? Part C is, what is the maximum height of the javelin? Well, that's going to be up here at the vertex. Okay? And this is a maximum again, so I'm going to go second trace, do number 4 maximum. I have to do a left bound. I'm going to get up close up there, press enter. Over the hump, right bound, press enter. And my guess, I'm going to go to the middle. And my vertex, it looks like 1.999. And again, we're going to round that to 2. So it's 270. And to answer letter C there, what is the maximum height? Again, the height is the y-coordinate. It's going to be 70 feet. Okay? If I had another question that asked, how long did it take to reach that height? Well, that would be our x-coordinate. That would be 2 seconds. So we're going to have to make sure we read the question carefully. Okay? All right, a lot of times they're going to give you the equation. In fact, most of the time I think they're going to give you the equation. If not, you can write the equation. Just remember, go back to this one right here and fill in the pieces. Okay? All right, so we're graphing parabolas today. Okay? Thanks for tuning in.